This is the Protea simulation of our circuit. We have implemented this Protea simulated circuit for our project. Here you can see so many sliding switches. This sliding switch, during the sliding switch, we can start our clock, and the output of our clock has been shown on LEDs. We have used so many ICs and logic gates for the implementation of the circuit. Here you can see 7432 OR gate. This OR gate actually takes so many input signals. These input signals comes from sliding switches. We have used the sliding switches for setting the alarms. You can set the alarms at minute and hours. From the 7432 OR gate, signal passes towards the 4520 up counter. From the up counter, signal passes towards 403 and 30 CMOS XOR gate. From here, we can see the signal passes towards 4019 selective AND OR gate, and from 4019, signal passes towards the LEDs through BCD 7-segment decoder. Now, we have preset alarm at minute 1. When the minute coincides with the alarm, the LED glows. Here you can see the LED has been blown. This is how the software works.
So here we are implementing the project on the hardware board. So we see the breadboards, and on it the chips are placed and wires are already connected on the boards. Connection has been driven from one board to another, and the whole setup is made so from one level to another that the connection becomes more and more simpler. Here we easily can see the chips, the switches, and registers parallel with these switches, and more registers here, and more chips and breadboards. Let's see what happens. Here there are two more chips, and there is the alarm signaling LED, there is the power battery, and there is the last breadboard. We move on to the switches. Now the switches can be used to implement the alarms, which are for the indicators of hours and minutes. We can also use the same circuitry in a reduced format to use it as a stopwatch using some other switches, and all the switches are push type switches. It means when we press the button, the circuit activates, and when we lift it over, then the previous circuit is activated once more. Let's see. The overview of the circuit is here. So come back with the circuit. We see the glowing LEDs, that means the clock is running here. And now we move to the breadboards, and now we are moving to the clock in a very few short moments. And here is the clock. It shows 12:25 and 37 seconds. We again move on to the all over the breadboards, and over, and come to the front again, and we are pointing to the LED. We have an alarm preset at 12:30. Let's see what happens. It's 12:30 and the LED glows. That means the alarm works for the circuit. The alarm glows for 1 minute and automatically shuts down when it's 12:31. Let's see for the 12:31. We're waiting, still waiting. The LED is glowing. All going okay. It's nice. The clock is working nicely. And it's now 12:31 and the LED is off.